Okay. Good morning. So now we are going to establish the flux loop of the vector control. So as we know, VRD, that is the rotor voltage on direct axis of synchronous rotating reference frame, that is basically is equal to rotor resistance into that current, that particular current, that is RR into IRD plus ddt of psi RD, that is the rate of change of rotor flux, plus minus omega s minus omega r, that is the slip, because it is a rotor side, that into psi RQ. But to establish the vector control, we need to make that psi RQ 0. So this term entirely will vanish, and in rotor construction of asynchronous induction machine, the rotor's bars are short circuited through short circuit ring at the both end. So basically the rotors are short circuited from both the end. So as it is short circuited, so this voltage VRD should be 0. So VRD is 0, and to make the vector control psi RQ we made 0. So these two terms will vanish. So remaining is ddt of psi RD plus RR IRD is equal to 0. Now this psi RD actually as psi RQ is 0, so psi RD basically that is the total flux which is coming from the magnetization. So now I am assuming the psi RD is nothing but the mutual part into the magnetizing current, that is Lm into IMR. So ddt of Lm IMR plus RR IRD is equal to 0. We know psi RD is equal to LRR into IRD plus Lm into ISD. So now as this psi RD is total flux and getting generated from the magnetization, so that is equal to Lm into IMR. Now if I find out the value of IRD, so IRD is equal to, this term will go that side, so Lm by Lr into IMR minus ISD. So now this IRD term is replaced here, then we will get that such equation. Now we are cancelling that Lm, so ddt of IMR plus, so basically here term is RR by LR. So if I put 1 by LR by RR, so that is the rotor time constant. Tau r is the rotor time constant. And in Laplace domain, S plus 1 by tau r into IMR is equal to 1 by is equal to ISD by tau r. Now at steady state, if the systems are in relaxed state, then IMR is equal to ISD. Okay. So now what is the, so to get the flux, this is the flux, this IMR is the flux producing current. So to get that, this will be coming from VSD. So if that is the, so now the flux loop will be very simple. So there will be a reference value of flux in terms of ISD. Normally that should be the rated current of the machine always, and this is the ISD component generating through the producing by the machine after conversion from ABC to DQ. It is generating the error signal, and this is the compensator is introduced. Eventually this should be PI regulated. This will give the VSD out, means the stator direct axis voltage. Okay, so this is the flux loop. Thank you.